All right, we're going to go ahead and do more AP review. So now we're doing 2012 AB BC free response 5. It is the same question on both the AB and BC exams. All right, so I'm going to read you the problem. Hopefully you have it in front of you. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, it weighs 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then db dt equals 1/5 the quantity 100 minus b. Let y equals b of t be the solution to the differential equation above with the initial condition b of 0 is 20, meaning the bird's starting weight is 20 grams. All right, A, is the bird gaining weight faster when it weighs 40 grams or weighs 70 grams? Explain your reasoning. Okay, so dB dt is the rate of change, right? dB dt is the rate of change of the bird's weight. Come on, Hogan, you can spell bird. Okay, of the bird's weight. Okay, whereas B of t itself, right? B is the bird's weight at a given time, right? So that's the bird's weight. All right, so when we're asked if the bird is gaining weight faster at these two different weights, really all we need to do is we need to figure out what dB dt is at those two values. So dB dt at the moment when the bird weighs 40 grams would be 1/5 of the quantity 100 minus 40, which is a 1/5 of a 60, which is a 12. And because it's dB, which was the weight, grams, over time, which is in days, it's grams per day, right? So 12 grams per day. dB dt when the bird weighs 70 grams, so B equals 70, would be 1/5 times the quantity 100 minus 70, which is a 1/5 of a 30, or 6 grams per day. So it's clear that the bird is growing faster when it weighs 40 grams because it's going 12 grams per day. So the answer is faster when it weighs 40 grams. And if you want to give the reason, it's because 12 grams per day is greater than 6 grams per day. All right, so that is our part A. 12 is bigger than 6. So the bird is gaining weight faster when it is gaining at 12 grams per day. So let's now erase A and talk about B. All right, part B. So in part B, we're asked to do a couple things, okay? So the first thing we're asked to do in part B is find d squared b dt squared in terms of B, and then use that quantity to explain why the graph that we're given cannot possibly be the correct graph for B, okay? So we'll walk through this now. Let's start by finding d squared b dt squared, right? So there's a couple ways you can do this. For me personally, I think it's easier if you distribute this 1/5 and make it a 20 minus a 1/5 b. It's up to you. You don't have to. I think it's easier. If you do that, when you take the derivative, you derive 20 and get a big fat 0, and you derive the negative 1/5 b and get a negative 1/5 dB dt, which is the thing some of us forget. A lot of people will just get the negative 1/5 as an answer, which isn't right. You need this guy. So once you have that, remember that the question said in terms of B, which means you shouldn't have a dB dt. But look, you already have dB dt in terms of B. So you're going to get that your answer, d squared b dt squared, is a negative 1/5, right, because that 0 is gone, times the quantity 1/5 times 100 minus b. And you can clean that up however you want. It's technically a right answer at this exact moment. If you want to make it a negative 1/25 in front of a 100 minus b, that's great. If you want to clean it up further and say that this is a negative 4 plus a b over 25, that's also fine. I think this is probably just fine and works a-okay. So that's my d squared b dt squared. Now we have to take that answer and we have to explain why the graph that we are given is wrong. So one of the things you want to do in a situation like this is think, well, what information does the second derivative normally give me? Because I'm trying to counter what they've given me and show why it's wrong. So in general, a second derivative will tell us the concavity, right? This tells us the concavity of the b of t graph, right? The second derivative gives us the concavity of the graph. So what I want to point out here is that if d squared b dt squared is negative, then the graph should be concave down. And if it's positive, the graph of b should be concave up. And if it changes sign, then the graph of B could be sometimes concave up and some concave down. Well, here's what I know. I know that this is very clearly a negative number. And I know that it doesn't make sense. Well, for lack of a better explanation, I know that on the given graph, the biggest B, right? So I was going to say it doesn't make sense for the bird to weigh more than 100 pounds, but that's not true. That would be me misspeaking, so just ignore me. The biggest B on the graph that we're given is B equals 100, right? So what I want you to notice is if B is smaller than 100, this whole thing is a positive number. So while this isn't always positive, it is always positive on the window from 20 to 100, and that's the window of the graph I'm given. So if you look at the graph that I'm given, right, the graph that we have, and I'm going to do a very terrible version of this graph because I'm just absolute crap at drawing things, but it goes from B is 20 to B is 100. And essentially what it is a logistic curve. It increases very sharply and then levels off at 100, which would be the carrying capacity if this were logistic. But what I want you to notice about this graph is that this graph is concave up for the first part, right? And we've just established that this graph shouldn't ever be concave up because it's got a negative number in front of something that should be a positive number, meaning that d squared b dt squared should be less than 0 on the interval from 20 to b to 100, which is the graph that I'm looking at, where b is 20 to b is 100. And on that window, this thing should be concave down, and it's not. It's concave up right here, which means it's wrong. So what makes this graph wrong is that d squared b dt squared is negative, so b of t is always concave down on this window from 20 to 100. So that's what makes this thing wrong. All right, so that's our job, is to say what makes this graph wrong, and that's what makes this graph wrong. Now, the third part is the part that's probably worth all of the big points, and the reason for that is that anytime we're given a separable differential equation, which is what this is, we're going to be asked to solve, and that's going to be the bulk of the points. So part C says, use separation of variables to solve for b of t. So, I have db dt equals the 1/5 100 minus b. So separation of variables means that this db stays on the side he's on, right? So my db stays on top right here, and I'm going to take anybody with a b and divide that guy over, and my dt is going to switch to the other side. Now, what you choose to do with the 1/5 is up to you. I chose to keep the 1/5 with the t. You certainly don't have to. So what I did was I made this a db over 100 minus b. And on the other side, I made this a 1/5 dt. Notice that you get 0 out of 5 points, according to the AP, if you don't do it, if you don't separate the variables. So it very clearly says 0 out of 5 if no separation of variables. Now we're going to do the antiderivative for both sides of this. So this is a natural log, but because there's a negative in front of the b, if you did u sub, if you made your whole u the 100 minus b, your du would have a negative db. So, essentially, I get that this is the negative natural log of the 100 minus b in that absolute value. On the other side, I get a 1/5 t plus c. We generally put the c on the independent variable side. Now, because it said to find the solution y equals b of t, right, they specifically said that they wanted the solution to be y equals b of t. That means you need to solve for y, right? So this is code for solve for y, right? So essentially, or solve for y or solve for b, right? So solve for y or solve for b, right? So we have to solve essentially for this b. So what I'm going to do is I'm going to start by dealing with this negative. I'm going to go ahead and divide that negative over and get the natural log of 100 minus b equals a negative 1/5 t plus, I'm just going to go ahead and call that c sub 1 because it's still an arbitrary constant. When I exponentiate both sides, I'm going to make this a 100 minus b. I'll lose the square root, and then when I do e to the c sub 1, right, so keep in mind that this is e to the negative t over 5 times e to the c sub 1, which I'm going to rename a new c sub 2. So c sub 2 e to the negative t over 5, right? And it's up to you when you choose to plug in the value that they gave you to find your c. You could do it now if you want. entirely up to you. I'm not going to. I'm going to go ahead and move the 100 over. So negative b equals c sub 2 e to the negative t over 5 minus 100. When I divide by negative 1, sorry, I lost you guys there for a sec. When I divide by negative 1, I'm going to get that, well, let me actually erase the top and let's start up here because I'm low on space. So when I divide by the negative 1 or times by negative 1, whichever option you prefer, I get that my b of t is a 100 minus my c sub 2 e to the negative t over 5. I'm now going to go ahead and plug in the fact that b of 0 is 20. So b of 0 is a 20. So that's 100 minus c sub 2 e to the 0. So I think I get 20 minus 100 is my negative c sub 2. I think I get an 80 as my c sub 2. So my final answer is b of t equals 100 minus 80 e to the negative t over 5. And that is my final answer. So that's where most of the points lie. Anytime you do a separable differential equation and you're asked to solve, the bulk of the points lie in the actual solving of the Diffie-Q.